Hey guys, today we are looking at some multiple representations of patterns. So I see that first we're given a verbal representation, then we're given a tabular or a table, and then we have a graph. So they tell us that Janet's making necklaces to sell to her friends. She's tracked her use of string in the following table. And then she created this graph using the data recorded in the table. So what that tells me is that all of these representations, our verbal, our table, and our graph, show the same thing, just looking in a different way. So I'm going to look and see my 0.23 is on there. My 0.3 and then 4.5 is on there. 4 then 6. And 5 and 7.5. But over to the right, if we look, we want to know which statements are true and false and why. So the first statement is that it takes 6 feet of string to make 4 necklaces. So I'm going to go look at my table, and I'm going to find where under string it says 6 feet. And what this tells me is that when the string is 6 feet, 4 necklaces are made. So this is a true statement. For the statement B, we add 2 to the number of necklaces to get the amount of string needed. And so I'm going to look, if I add 2 to each of the necklaces, notice that only works for 4 plus 2 to get to 6. So it doesn't work here, doesn't work here, only works here, and doesn't work here. So because that pattern or that rule does not work for all of the different coordinates, that's not an accurate, it's not an accurate rule that we can use. So this is a false statement. And we can say it's false because 2 plus 2 does not equal 3. So notice I use this first point to be my counterexample because I can't just say something's false, I have to justify why. And then C, this is an additive pattern. And so when we take a closer look, I see that 2 plus 1 is 3. But 3 plus 1 does not give me 4.5. So that tells me right away this is not an additive pattern. And instead it is actually multiplicative. All right, thank you.